The code is installing two packages, PyAlgoTrading and PyAlgoStrategiPool, as well as the TALib library. These packages and library are commonly used in algorithmic trading to implement trading strategies and perform technical analysis. This code imports a class called strategy_base from the pyalgoTrading.strategy.strategy_base module. It also imports some constants from the pyalgoTrading.constants module. These imports are necessary to define and implement a trading strategy using the PyAlgoTrading library. This code defines a strategy for algorithmic trading called a regular order strategy. It inherits from a base class called strategy_base. In the initialization method, the code retrieves the values of two parameters called time period 1 and time period 2 from the strategy_parameters dictionary. It also initializes a variable called main_order to none. The initialize method sets the main_order variable to an empty dictionary. The code also includes two static methods, name and versions_supported. The name method returns the name of a strategy as a string, while the versions_supported method indicates the versions of the AlgoBulls engine that are supported by this strategy. Overall, this code defines a strategy for algorithmic trading that calculates two time periods and manages a main order. This code defines a class called strategy_regular order that is derived from the strategy_base class. It implements a strategy for algorithmic trading using exponential moving averages, EMA. The get_crossover_value function calculates the EMA values for a given instrument's historical data and returns the crossover value using a utility function called crossover. The strategy_select_instruments_for_entry function is responsible for selecting instruments for potential entry based on the crossover value. It iterates through a list of instruments and calls the get_crossover_value function for each one. If the crossover value is 1, indicating a bullish crossover, the instrument is added to the selected instruments bucket and a sideband information dictionary with the action buy is appended to the sideband info bucket. If the crossover value is -1, indicating a bearish crossover, and the strategy mode is set to intraday, the instrument is added to the selected instruments bucket and a sideband information dictionary with the action cell is appended to the sideband info bucket. Finally, the function returns the selected instruments bucket and the sideband info bucket. This code defines a class called strategy_regular order, which is a strategy for algorithmic trading. It inherits from a base strategy class. Within this class, there is a method called strategy_enter_position. This method is responsible for executing a trading order based on a given candle, instrument, and sideband_info. If the action value in sideband_info is buy, it calculates the quantity of lots to buy based on the number _ of lots and instrument's lot size. Then it creates a buy order using the broker's buy order regular method with the appropriate parameters and assigns it to the main_order dictionary under the corresponding instrument. If the action value in sideband_info is sell, it follows a similar process to create a sell order using the broker's sell order regular method. If the action value is neither buy nor sell, it raises a system exit exception with an error message indicating an invalid sideband_info value. Finally, the method returns the created order object from the main_order dictionary for the corresponding instrument. This code implements a strategy for exiting positions in algorithmic trading. The strategy is based on the exponential moving average, EMA, crossover. The code defines a class called strategy aim regular order, which is a subclass of strategy base. Within the class, there is a method called strategy_select_instruments_for_exit. This method takes two parameters, candle and instruments_bucket. In this method, a new list called selected_instruments_bucket is created, as well as another list called sideband_info_bucket. A loop is then performed over each instrument in the instruments_bucket. For each instrument, the code checks if there is a main_order for that instrument. If there is, it calculates the crossover_ value for that instrument using a function called get_crossover_value. If the crossover_ value is either 1 or -1, it means there has been a crossover of the EMA, and the instrument is added to the selected_instruments_bucket list. Additionally, a dictionary with an action key set to exit is added to the sideband_info_bucket list. After the loop is completed, the method returns the selected_instruments_bucket and sideband_info_bucket lists. Overall, this code selects instruments for exit based on the EMA crossover condition, and returns the selected instruments along with sideband information. This code is a part of the Algorithmic Trading Code Strategies step-by-step project. It is a class definition called strategy aim regular order, which is a subclass of strategy base. The function strategy_exit_position is defined within this class. It takes three parameters, candle, instrument, and sideband_info. It checks the value of the action key in the sideband_info dictionary. If the value is exit, it calls the exit_position method on the main_order object associated with the given instrument. It then sets the main_order instrument to none and returns true. If the action key in sideband_info is not exit, the function returns false. Overall, this code is responsible for handling the exit logic of a trading strategy based on the action value provided in the sideband_info. This code imports the necessary libraries and classes for implementing algorithmic trading strategies. It includes the inspect library for inspecting and accessing attributes of objects, and the AlgoBulls connection class from the pyalgotrading.algobulls module for establishing a connection with the AlgoBulls trading platform. Additionally, it imports the strategy aim regular order class from the pyalgostrategy_ema_regular_order module, which likely contains the implementation of a specific trading strategy based on exponential moving averages and regular order placement. The purpose of this code is to prepare the required tools and strategies for algorithmic trading. This code initializes a connection to the AlgoBulls platform, which is most likely used for algorithmic trading. The AlgoBulls_connection variable is assigned the value of an instance of AlgoBulls connection, suggesting that there is a class or module in the code that handles the communication and connection to the AlgoBulls platform. This code is calling a method called get_authorization_URL from the AlgoBulls_connection object. The purpose of this method is to generate a URL that can be used for authorization in algorithmic trading. This URL is likely used to authenticate the user and grant access to specific trading functionalities. This code sets an access token for a connection to the AlgoBulls platform, which is likely a platform for algorithmic trading. The access token is necessary to authenticate the connection and gives the user permission to perform various operations on the platform. The specific access token used in this code is provided as a parameter to the set_access_token function. The code you provided is trying to print the source code of the strategy aim regular order function. The inspect.getSource function is a part of the inspect module which allows us to retrieve the source code of a function or a class. In this case, it is trying to retrieve the source code of the strategy aim regular order function and print it. However, since the specific function strategy aim regular order is not provided in the code snippet, It is difficult to explain what the function does without further information. This code calls the create_strategy function from the algobulls_connection module and passes the strategy irregular order class as an argument. The create_strategy function is responsible for creating an instance of the specified strategy class. It is likely a part of an algorithmic trading platform, used to develop and execute trading strategies. The strategy irregular order class is likely a custom strategy implementation using the exponential moving average (EMA) indicator. It is responsible for generating trading signals and managing the execution of orders based on the EMA values. By calling this code, a new strategy instance is created using the strategy irregular order class, which can then be used to define and execute trading strategies within the algorithmic trading platform. The provided code is creating a strategy for algorithmic trading using the strategy irregular order class. The algobulls_connection.create_strategy method is being called with the strategy irregular order as the argument. The override equals true parameter indicates that if there is already an existing strategy with the same name, it will be overwritten. This code defines a class called strategy_order, which is a subclass of strategy base. The class has several attributes such as fastMA_period, slowMA_period, signal_period, stop loss, target, and trailing_stop loss, which are initialized based on the strategy parameters passed to the constructor. The class also has a main_order attribute, which is initially set to none. The initialize method sets the main_order attribute to an empty dictionary. The name method returns the name of a strategy as macd_order strategy. The versions_supported method returns the version of the strategy as 3.2.0. This code is a part of a strategy for algorithmic trading. It defines a class called strategy_order that inherits from a base strategy class. The function get_crossover_value takes an instrument as input and retrieves historical data for that instrument. It calculates the MACD align, MACD signal, and MACD histogram using the historical closing prices. The crossover value is then obtained by comparing the MACD line and MACD signal using a utility function called crossover. The crossover value represents whether the MACD line crossed above 1 or below -1, the MACD signal. The function strategy_select_instruments_for_entry is responsible for selecting instruments for entry into a trade. It takes a candle in the bucket of instruments as input. It iterates through each instrument in the bucket and calculates the crossover value using the get_crossover_value function. If the crossover value is 1, it adds the instrument to the selected instruments bucket and appends a dictionary to the sideband info bucket with the action set to buy. If the crossover value is -1 and the strategy mode is set to intraday, it adds the instrument to the selected instruments bucket and appends a dictionary to the sideband info bucket with the action set to sell. The function returns the selected instruments bucket and sideband info bucket, which represent the instruments selected for trading and the corresponding actions to be taken, respectively. This code is a part of a strategy called strategy mixed bracket order in algorithmic trading. The strategy enter position function is used to enter a position in the market based on the given sideband information. If the sideband action is buy, it calculates the quantity of lots to be bought, gets the last traded price, LTP, of the specified instrument, and places a bracket buy order using the broker's buy order bracket function. The order includes the instrument, order code, order variety, quantity, price, stop-loss trigger price, target trigger price, and trailing stop-loss trigger price. If the sideband action is sell, it performs the same steps as the buy action but places a bracket sell order using the broker's sell order bracket function. If the sideband action is neither buy nor sell, it raises a system exit with an error message indicating the invalid sideband_info value. Finally, the function returns the main order associated with the specified instrument. This code is a part of a larger algorithmic trading strategy. It defines a class called strategy mixed bracket order which inherits from a base strategy class. Within this class, there is a function called strategy_select_instruments_for_exit. This function takes in two arguments, candle and instruments_bucket. The function first initializes two empty lists, selected_instruments_bucket and sideband_info_bucket. It then iterates through each instrument in the instruments_bucket. Within this loop, it checks if there is a recorded main order for that instrument, using the main_order attribute. If the main order exists, it retrieves the crossover value for that instrument using the get_crossover_value function. If the crossover value is either 1 or -1, it means there is a crossover signal indicating an exit point. In this case, the instrument is added to the selected_instruments_bucket list and a dictionary containing information about the action, in this case exit, is added to the sideband_info_bucket list. Finally, the function returns the selected_instruments_bucket and sideband_info_bucket. This code is a part of a strategy called strategy mixed bracket order in algorithmic trading. It includes a function called strategy_exit_position. Inside the function, it first checks if the sideband information indicates that the action is to exit a position. If it is, it proceeds to exit the position using the main_order object for the specific instrument. After that, it sets the main_order object for that instrument to none, indicating that the position has been exited. Finally, it returns true to indicate that the position was successfully exited. If the sideband information does not indicate an exit action, it simply returns false to indicate that the position was not exited. This code imports the inspect module and the strategy mixed bracket order class from the pyalgo_strategy_macd_bracket_order module. It also imports the AlgoBulls connection class from the pyalgo_trading.algobulls module. These modules and classes are essential for algorithmic trading and are used to implement trading strategies. The inspect module allows for introspection of live objects, which can be useful for debugging and accessing variables, modules, and functions. The strategy mixed bracket order class is a specific trading strategy that implements the MACD, moving average convergence divergence, indicator in a bracket order type. This strategy helps automate the buy and sell orders based on the MACD signal. The AlgoBulls connection class provides a connection interface between the algorithmic trading system and the AlgoBulls platform, facilitating the execution of trades and accessing market data. Overall, this code sets up the necessary components for implementing and executing algorithmic trading strategies using the MACD indicator and bracket orders. This code creates an instance of the AlgoBulls connection class, which is likely a module or library used for connecting to the AlgoBulls trading platform. By assigning the instance to the variable AlgoBulls_connection, the code establishes a connection to the AlgoBulls platform, allowing for further interaction and execution of trading strategies. This code is calling the function get_authorization_URL from the algobulls_connection object. This function likely returns a URL that is used for authorization in algorithmic trading. The purpose of this code is to obtain the authorization URL so that the algorithmic trading system can connect to a service or platform and perform trading operations. This code connects to Algobulls, an algorithmic trading platform, using the access token 80B7A69B168C5B3F15D566888418F2D5E2AB2C. This code snippet imports the strategy _order class from an unknown module. It then prints the source code of the imported class using the inspect.getSource function. The strategy _order class most likely contains the code implementation of a trading strategy based on the moving average convergence divergence (MACD) indicator and the use of bracket orders. The purpose of printing the source code may be for debugging or understanding the logic of the strategy. The given code initiates a connection to an algorithmic trading platform called algobulls_connection. It then proceeds to create and implement a strategy called strategy _order on this platform. The details and functionality of this strategy can be found on the provided website. This code is a method call that creates a strategy for algorithmic trading using the MACD, moving average convergence divergence, indicator in a bracket order. The algobulls_connection object is being used to create the strategy, and the strategy _order class represents the specific strategy being used. The overwrite equals true parameter indicates that any existing strategy with the same name should be overwritten.